Hello everyone, my name is Mohammad Mohammad Islam. I am from Kuwait. Today I am going to talk about something that affect all of us, that is actually electricity, especially how we can predict power demand more accurately using artificial intelligence. That is our work. The title of my presentation is a hybrid CNN-BiLSTM-Attention model for enhanced electrical load forecasting in Bangladesh. First, I will give a brief introduction. Next, I will highlight the related work. Then, I will explain the problem we address. I will also share the motivation and main objectives. After that, I will describe the methodology we used. Then, I will present the result and discussion and discuss the findings also. I will briefly mention the impact, outcome, and the limitation. Actually, predicting electricity demand is really matter. Every single day, power system operator have to decide how much electricity to generate. If they generate too much, money is wasted on fuel. If they generate too little, we have blackout. In Bangladesh, this is especially important. Our country is growing rapidly. More factories, more homes, more people using electricity every day. But we don't have unlimited power generation capacity. So, accurate forecasting is not just about the saving money. It's about keeping our light on and the supporting economic development. There are a lot of related work regarding the electrical load forecasting. Older methods like ARIMA and exponential splitting were the standard for a long time. They work okay for simple pattern, but electricity demand is not simple. It has daily peaks when people come home from work. It has weekend versus weekly differences. And it responds to weather, holiday, and special events. These traditional methods just can't handle all of the complexity. Recently, deep learning models like LSTM have become very much popular. Some researchers like Bangladesh have tried them too, but there is a gap. Most studies use just one type of model. They use either like CNN or LSTM or BiLSTM, not both together. And even nobody has tried combining CNN, LSTM, and attention mechanism all together for Bangladesh national grid. That's exactly what we did. So, what is the actual problem we are solving? Bangladesh electricity demand is unpredictable and very much complex. It fluctuated constantly because of industrial variation, residential peak hours in the evening around like 6 p.m. and weather dependent consumption also. And it is not just a random noise. There are real patterns hiding in the data. Daily cycle, weekly patterns, seasonal changes, and so on. The challenge is that no single technique can capture all the pattern at once. That is why we needed a hybrid approach. What is the motivation and objective of our actually to doing this work? First, economic impact. Better forecast mean lower fuel cost for the power system. Second, grid stability. Accurate prediction help prevent blackout and frequency problem. Third, it set the foundation for integrating renewable energy like solar, wind in the future. And fourth, it gives the policymaker data-driven insight for planning. Our research objective is simple but ambitious. Develop a new hybrid model especially designed for Bangladesh electricity demand, create a special features that capture Bangladesh specific pattern and benchmark against existing model and achieve less than 2% error, which is our target actually, which is good enough for the so that that can be enough for real operation uses. Let me explain the methodology. What we actually did, we collected 5 years of hourly electricity data from Bangladesh National Grid. That is about 43,000 data point covering January 2021 through September 2025. First, we clean data. We fill the missing values, remove obvious outlier, and normalize everything to the standard scale so that the neural network can learn better. We created lag feature. Basically, we told the model the demand right now is similar to the demand 1 hour ago, 1 day ago, or 1 week ago. We added rolling average and rolling standard deviation over different time windows. We encoded the time day of week using a sine and cosine function so that the model understand. For training, we use 40% of the data for training, and held out 20% for testing. We use Adam W optimizer with early stopping to prevent overfitting. The key innovation is our model architecture. The model has three main parts working together. First, the CNN layer. They are good at finding local patterns, sudden jumps or drops in demand. They actually like feature extractor, finding the importance of short-term patterns. Secondly, BiLSTM layer. This is the bidirectional LSTM, which means it reads the time series forward and backward. This is powerful for learning long-term dependencies and understanding how dependence evolves over time. Thirdly, the attention mechanism. This is the novel part. Attention allows the model to focus on the most important time steps. Instead of treating every historical hour equally, it learns which hours are most relevant for predicting future demand. Is it the peak hour that mattered most, or the 10 from the last week? The attention layer figures this out automatically. Actually, the model has about 200,000 parameters. It is lightweight enough to run in reasonable time. Let me show the result. We tested three models. BiLSTM baseline got 2.76% error. Adding CNN improved it to 2.32%. But when we added attention, it dropped to 1.52%. That's a 40% improvement over the baseline. The attention mechanism learns which past hour matter most for the prediction. A 1.52% error rate means real benefit for Bangladesh. Operator can schedule power plant more accurately and save fuel. It reduces unnecessary spinning reserve. The grid runs more stable, and we prevent unnecessary blackout. Overall, this could save like $1 million annually. This is the first CNN-BiLSTM-Attention model for Bangladesh National Grid. We used 40,000 hour of real operational data, almost 5 years. We achieved 40% RMSE reduction and 1.52% MAPE operational grade accuracy. We created special features for Bangladesh unique demand pattern, like evening peak or seasonal variation, like that. In about the limitation, we didn't include weather data, renewable energy generation, or real-time factory errors. Training required GPU hardware, but despite this limitation, we still got 1.52% error, showing huge potential for improvement once we add these factors. We developed a CNN-BiLSTM-Attention model optimized for Bangladesh using real grid data from 2021 to 2025. We achieved 40% RMC reduction and 1.5% MEP, accurate enough for the real operational deployment. This is the first application of attention mechanism in Bangladesh load forecasting. In our future work, integrating weather data, test at seasonal levels, developing adapting learning systems, and incorporate economic indicator, and explore ensemble method and adapt this approach to other development countries. There are a lot of things we can do, or anyone can do in future work. That's all about my side. Thank you for listening. Thank you so much.